Okay, so 148, we did a 1 to 8. So what's going on number 1 and number 2? It's like what we did at the bottom of the quiz on the 5-6 quiz, where I marked up some pictures, the book has marked up some pictures, and you're trying to say what's given from the way they marked it and what you're trying to prove. It's easier to spot the thing you're trying to prove. How does that stick out like a sore thumb, the thing you're trying to prove? It has a question mark on it. So whatever has the question mark on it, that's what you're trying to prove. Whatever doesn't have a question mark on it, that's the things that you're given. One thing we need to be a little more careful of is our punctuation sometimes. If you're doing angle symbols, make sure you're doing the angle symbol twice. And if you're just doing the angle symbol, which symbol joins those? Equal or congruent? Congruent. If you wanted to do the equal sign, how do you have to change the angle things? You have to put measures on them if you're using the equal sign. For sides, if you want to do the segment hats on the side names, then what symbol will you use? Put segment hats on segments, what, equal or congruent then? Congruent. Congruent. If you want to do the equal sign, what do you have to do?
Just the like.
Yeah, just pull the segment hats off, basically. Just be a little consistent with your punctuation. Some of you guys, when you're using ASAs, you're not using the triangle symbol. Like you want to say triangle congruent to triangle and use your triangle symbols. That the punctuation's been a little bit off kilter. But 1, 2, does anybody need information on 1, 2? 3, a lot of the answers are probably in the back. 3 is like a super ridiculous long proof. They're having you fill in the blanks. The idea of fill in the blank proofs on the test is never going to happen again. So the fill in the blanks are like okay-ish on the homework. I'm never going to do a fill in the blank kind of proof on the test. The test proofs are just going to be here's a proof to it, like we've been doing on the backs of the quizzes. 1, 2, 3. Anything 1, 2, 3? Okay, 4 to 7. Sometimes people will ask me, do I have to draw the picture 5 times because they use it like on 5 proofs in a row? Or can I just draw the picture once? What do you think the theory is on that? Copy it once, copy it each time on its own.
Each time?
Each time on its own. Because what's going to be different on every proof? Like the marks. And the marks are important to us. So you'll need to draw a picture on 4, mark it up. Draw the same picture on 5, mark it up. Same thing on 6, mark it up. Same thing on 7, mark it up. Copy given, copy picture, copy proof, do the columns, and then we'll talk through these proofs. So for number 4, I've already marked this up with the givens and the proof. And if we focus on this triangle and this triangle, you can safely act like this never even existed, because that really has nothing to do with the triangles that we're using. If we just focus on those triangles, how many pieces did they already give us on number 4? 3. Woohoo! So we can already say right out of the gate for reason 2 or statement 2 of our proof, what can we say? Triangles are congruent right away in number 2. What reason can we see from looking at the markings?
SSS.
It's SSS. And then these, we can finish that proof in a third step with reason? CPCTC. Something about 4, pretty short one on 4. 5 is bigger. Okay, so for 5, again, you don't necessarily need this. So if you find that distracting, just take it out. It doesn't really do anything for you. When we look at the triangles that we have, how many pieces, different voice this time, how many pieces did they give us this time? 3. So, woohoo. Number statement 2, we're already going to be able to say that the triangles are congruent. Let's get a different voice going though from our studio audience. When we go to do the proof, and they want us to prove something about ABC or BDE, why are those a problem on 5? So 1 was given, 2 we say triangles are congruent. Did we say why? Why are triangles congruent? What's the reason? SAS. 3, we'd like to pick out a CPCTC. Why are these angles on 5 that they want us to prove problematic? Yeah, they're too big. They're too big to be contained in one of these smaller triangles. So here's our out. We find our page and says, like there's a section 4A here that says if the items in the conclusion aren't in the triangle, pick a CPCTC that's in the triangle that like relates to that. So what part of this triangle has something to do with this angle that was too big to be contained?
Angle ADB.
Angle ADB. No, ADB is outside the triangle too. Who's inside the triangle that plays a role in this angle's life? ADE. So angle ADE is in the triangle. That would be congruent to who from this triangle? BDC. So for 3, that would be your CPCTC. You'd want to talk about angle ADE and you'd want to talk about angle BDC. If you don't have this paper on hand, pull it out and have it nearby because we can look for answers on this paper. So if angles are the wrong size, who?
Not that question. What is this?
Just throw it in a folder somewhere. It proofs that you know are right.
Okay. So there's enough proof for the 5, 6.
Not for you. We'll double the next proof next time that you're here. Okay. If angles are the wrong size, who's in play?
Is it A for speed?
That's coming, but there's another factor first. Angles are the wrong size? Angle addition postulate. There's a sentence on here that'll say, when angles are the wrong size, we're going to use the angle addition postulate. And then if we read on, we get to that other idea. If stuff is too small, we'll use APE to make it bigger. So our CPCTC is small. We need to make it bigger. We're going to use APE in that. We'd use SPE if we were trying to make things shrink. And then who's along for the ride? Transitive is correct. That's as far as I'm going to take you with that today and see if you can do that. But this one's going to finish with angle addition postulate, APE, and transitive. Grand total on that, I think it's a 6-step proof. So we'd have given, triangles congruent, CPCTC, and then angle addition postulate, APE, transitive. It should be 6. If you want to find a pattern example of how to do the statements and reasons, there was a proof that was spelled out the name Stein the other day from the notes that I had that had a big box drawn around the AAP, APE transitive collection of things. You could maybe pattern off of that, but that's the scheme of 5. 6 is a little weird. What's a little bit weird about 6 that probably raised your attention a little bit? Anybody observation on 6 that you're like, well, that's weird? It asks, can you do it? And when you get to 7, it asks, can you do it? And that should sit in your mind as like, that's a little bit odd. If you play the percentages, since they ask you that twice, what do you think about can you do it?
One's probably yes.
One's probably yes and one's probably no. So if we mark up 6 with the givens, this is how the givens get marked on 6. Again, if you find this little crossbar distracting and you just want to focus in on those 2 triangles, there's no harm in erasing that crossbar. The way they have this marked with these 3 facts, can you do it?
Isn't the angle EAD the given? Like EAD is given for BDC?
Was it?
Or CP?
No, not for 6. 6, they're saying angle E.
I was looking at
Yeah, angle E is a match for angle C. So can this be done? Why not? This is an SSA marking, and you have no ability to pick up other things. There's no linear pairs. There's no like reflexive stuff. There's no vertical angles. There's no anything to help you out. So they have you marked with an SSA kind of picture, and that's not a thing. So 6's answer is no, I can't do this. So likelihood is that 7, you probably can do it. So 7, They give you this angle matching this angle, which is nice because those are located inside. They tell you this side matches this side, which is nice because those are parts of triangles. But then they tell you that this angle matches this angle. And unfortunately, those two angles are both a little bit too big. They're too big to be contained in the triangles. If you find this bar distracting, just erase it. It's doing nothing again anyway. So we're back to a discussion from like 6 minutes ago or whatever that was. If angles are the wrong size, you're going to have to use angle addition postulate. We want to shrink them this time. So that's going to be SPD. And then along for the ride is going to come transitive. We're going to have to do that right out of the gate. So 2, 3, and 4, reasons 2, 3, and 4 are going to be angle addition postulate, SPE, and transitive. It may be hard to write those statements and reasons, but I'll at least drop you that hint and let you try. And we'll revisit that another time with a little bit more of a tip. If you do that, then your angles are the right size. Okay, then we're talking about these and those. Now how would the triangles be marked? We'd have our 3 pieces and we could do ASA, and then the big finish is still CBCTC. Something up through 7.
So, first 6, why can you?
Because it's marked side angle. This angle is not the included angle to make an SAS. It's SSA, and that's just not a thing. It's not, we have 3 triangle congruences, ASA, SAS, SSS. That's the only 3 ways we can get triangles congruent. If it was like an AAA or an SAA or any of those other ones, that's, you can't, those aren't proof reasons. You can't use it. Something else through 7? Okay, 8 is basically like the EMOST picture from the one example day that I did, that I gave you a paper that did some combinations. 8, how many useful, immediately useful givens did they give you to help you count your triangle to 3? 0 is correct. Okay, but they did give you some words that you should use. So we need to refer to this one back to our quiz knowledge. So commonly what you want to do for 2 is use a definition that's in number 1. We haven't done that a lot this year yet because the proofs have been a little bit shorter than average some days. But if there's vocab words in the given, you're going to want to use those definitions in 2, 3, 4 to get some momentum built. So what would be one definition you'd want to use early in 8? Maybe it's number 2, maybe it's number 3, that's kind of up to you. Definition of perpendicular you'd want to use early. What other definition would you want to use early? Midpoint. And it doesn't matter which one you do first. They're both in the givens. So let's do midpoint first because it's probably easier. If B is the midpoint and you use definition of midpoint, so what? What's that do for you?
It proves that MB equals BK.
MB equals BK. And then our count's at 1. Perpendicular. What's perpendicular mean our picture has? Right angles. Right angles by themselves are useless. Okay, but we could say, definition of perpendicular can let us say that this angle, ABM, is congruent to that angle, ABK. But that's not really useful to help us count to 3 unless we know another thing. What else do we know about right angles? Right angles are congruent. What's that? Theorem 4.4. Theorem 4.4 is going to almost always come right after you do definition of perpendicular. So definition of perpendicular would say those are right angles. Theorem 4.4 would say those angles are congruent. And then our count's 2. We're always trying to count the 3. So we need another piece. We ran out of words. It's got to be something from the picture. How does this picture help us?
reflexive.
Reflexive. We could say that AB equals AB by reflexive. And then our count's at 3. When the count's at 3, woohoo, we get to say that the triangles are congruent, and then we're going to pick out something after that for our reason of CPCTC. Can we say that these are a match by CPCTC? No. Why not?
They're outside the
They're outside the triangles. So what relationship does this have to somebody who's inside the triangle?
angle AMB.
Yep. Why is this a relationship with this that we've had before? It's a linear pair. So these things that I'm drawing the arrows to, those are the CPCTCs. And then we'll just pause and do a recount here. So 1 was given, 2-ish was definition of midpoint, somewhere early. 3 and 4-ish, somewhere early, would have been definition perpendicular, theorem 4-4. 5 would be reflexive, but could we have done reflexive in 2? Yeah. Somewhere in the mix, 2, 3, 4, 5 would be all that stuff. 6, the triangles are congruent. 7, do the CPCTC. Then we're going to have another bunch of hoops to jump through. So if we look to, again, the magic paper with pictures, it says on the one picture, the last one of this row of 5, definition of linear pair plus some others, or sometimes a helpful picture. And if we look down a little bit lower, who are the others? Who does definition of linear pair often friend up with? And supplement theorem. Those 3 things are going to be our finish, and what are we up to then, like 10? And the proof would be done in 10. 8, 9, 10 would be definition of linear pair, supplement theorem, or not, supplement postulate, then supplement theorem. I'm giving you the reasons. I'm not really giving you the statements. So if you're having trouble writing the statements, what I would do is I'd look at this paper that we did that other day. Find the reason. Find a statement from that paper and see if you can model it by using the names in this picture instead of the names in these pictures. But the statements that are on this should be about like how you're going to write the statements in your world. If you still can't do that, that's what tomorrow is for. We can go back and revisit some more stuff with some more tips, I suppose. 1 to 8 is a close on that assignment. I would guess most people will probably do better to keep those, because I would guess the angle addition postulate, APE, transitive statements are probably rough. I would definitely guess that the SPE statements on this one are going to be rough. If you can do it, great. If not, we'll get you some tips again tomorrow to make it a little bit better. Anybody, 1 to 8, anything I can do to try to help your 1 to 8 career along? A 9 probably made people grouchy. Why does 9 maybe make people grouchy? You know, it doesn't have a picture. They give you this paragraph and make you draw the picture. So what you don't want to do is read this whole paragraph and get scared. You just want to take like a little bit of read at a time and draw as you go. So it wants to have 2 lines, L1 and L2, be perpendicular at Q. So based on that sentence, I just want to start off drawing 2 lines, and they should be perpendicular. One of them I'm going to call L1, the other one I'll call L2. This point where they cross, I'm going to call Q, but I'm not going to label the Q yet, because if I drew this and I labeled a Q, and then I end up drawing a triangle that like wraps the Q up, I don't like it sitting there. That's my own personal style. Maybe that doesn't bother you at all. But if I have a picture like this, I'd rather have my Q like outside the triangle. But if I connect it this way, I'd probably rather have the Q like beside the triangle. So I don't know where I want my Q to be. I'm probably going to have to connect some more lines in a minute. So Q is going to be there, but I don't feel like doing that yet. There's a point P on L2. So you can draw that point anywhere on line 2. It doesn't matter. So do you want me to head to the left or head to the right? Head to the left. I wouldn't probably head real far, and I probably wouldn't stay real close because we don't know what else is coming. I'd probably just go sort of a medium length away. That's going to be a P on line 2. They want me to draw segments to 2 different points, R and S, on line 1. Chances are one of those points is going to be up while the other one's
Down.
down. But I'm gonna need to do an R and an S on this line in such a way that I'm gonna make some congruent angles, which means however far up I go for one, I should probably go
Down.
the same down for the other one. So I'll go up like a medium distance. What was one of those names? R. Go the same distance down, that's
S.
S. They wanted me to connect those. All the action is over there, so I'll throw my Q on now, and we'll go with that. So, reread just to make sure. Line 1, line 2, perpendicular at Q. From point P on the one, we connected to S and R on the other. They say RPQ, this angle, should be congruent to SPQ. That way. RPQ is that one. SPQ is that one. We're trying to prove RQ equals SQ. We'll go at that in a second. Where's our count? 1. We have those angles. Do you have any helpful words?
Perpendicular.
Perpendicular. So definition of perpendicular tells you that these are right angles. But what do you know about right angles? They're congruent. His definition of perpendicular's best friend is theorem 4-4. So we'll use those as a tag team. And now our count is 2. How can you get the count to 3? Reflexive. And those could really come in any order. Reflexive, definition perpendicular, theorem 4-4, some sort of jumble of those things. Put them however you want to put them. But only thing you have to do in sequence, the theorem 4-4 has to be after the definition perpendicular. But 2, 3, 4 would get that going. And then our count's at 3. Woohoo. Say that the triangles are congruent. And then these are in the triangles, so we're good. We can finish with our usual finish. CBCDC. Something about 9. Somebody who can see through the viewfinder, we're going to have to like slightly use the handle and turn the camera a smidge because I'm about to disappear in several of the pictures. Can we see the whole way to the edge now? 10. 10 draws this like super giant picture, some of which does not matter at all. So you could either draw the whole picture or you could just draw the picture that you need. For 10, all of the action is at the top and bottom triangles. So for 10, you could safely erase this whole middle thing and it really doesn't hurt you at all. How many pieces do you have already on 10? 3. Woohoo. We can instantly say that the triangles are congruent. The things that you're trying to prove, are they in the triangles? Yep. So number 3, you say,
SAS.
we've got SAS for 2 for triangles congruent, yeah. And then number 3, and we're done. 3-stepper and out. Something about 10. 11, they take a different approach. For 11, all the action is through the middle. So if you mark up your picture, you can sort of see everything's happening through the middle of that picture. This bottom little triangle, it has nothing to do with it. And this top triangle has nothing to do with it. So if you drew it and you left it, no harm. But if you erase it, it's a little bit less distracting. If we look at these triangles, how many things do you have marked? How many givens do we have for 11? 3. So usually I say woohoo. Except in this, I retract my woohoo because even though I have 3 pieces, how's it marked?
SAA.
No. AAA. All we have is angles. We have an AAA thing. Is AAA a way to say triangles are congruent?
No.
No. So we've got to pick up another piece somehow. How can we pick up another piece on 11? reflexive with who shared.
CD.
CD equals CD by reflexive would be 2. Then woohoo. We can say that the triangles are congruent, and since these are in the triangles, these sides are parts of the triangles, you can finish with by CBC to C. Something about 11. "12" is like a big giant thing. So 12, let's talk about 12. So 12, they say angle B congruent to angle E. That's the top and bottom corner angles. They say that DB equals CE. And that got complicated to draw, so I couldn't really put a hash mark on DB, because if we try to draw from D to B, it's like cut in pieces. DB is like this big, long, monstrous thing. Then they've got that matched CE. So I couldn't really mark CE, so I just drew this little like squiggle thing saying from C to E, this big long thing is the same distance as the BD big long thing. And then they want us to prove that triangle ABD is congruent to its friend. Well, here's something you might want to do. I think we'd all agree. This picture got a little bit crowded, a little bit confusing, a little bit like, I don't like that picture. Okay, so what they're talking about is triangle ABD. Pull that out to the side. This, I could re-represent there in a less tangly zone, A, B, D. I know this angle. I had this big long side that I had to mark with like a weird squiggle. And then I had this side right here that I marked with a single hash mark. I'm just gonna like transplant that over there and look at it. How many pieces do we have? 3. So maybe woohoo. Is it a woohoo? No. Why not?
So they're not like connected?
No. Why is this picture undesirable?
It's like SSA.
It's SSA. Is SSA a thing? No. This is another one that they ask, can you prove it? And the answer is no, because that's going to be an SSA. SSA is not a thing. If this were like an SAS, I'd have split out the other triangle too. The other triangle we were after was CDF, but I don't really see a need to pull out CDF to look at it, because we've already decided like this is a dead-end road, so we just give up on 12. Something up to 12. 13. What's a likely reason to appear on 13? Reflexive is likely from that picture. The 13 prove is a prove we have never encountered. So if you looked at 13 and thought, I've never proved that something is perpendicular before, that's true. If you thought, I don't have an example of how to do this from my life yet, that's true. If you thought, I can't do it, that's false. Even though I haven't said it in class yet, how could a person who is in this class know how to prove that something's perpendicular?
Isn't it like that thing about the sides of right angles, like for perpendicular?
Maybe, but even a better resource than our mind.
The triangles.
We're going to go that route, but we've never proved that things are perpendicular before. That's going to be hazy for everybody. Nobody's going to quite know how to manage that, but you do have a tool that could help you to do it.
The sheet.
Magic sheet. Thank you. This sheet tells you how to do it. Somewhere on this sheet it says, if you're going to have to prove that things are perpendicular, here's the stuff you're going to have to do. So 13, that's as far as I'm going to take it, is say, this paper tells you what reasons you're going to have to use to prove that something's perpendicular. It is on there. You find it, I don't want to tell you about that right now. Number 14, you're proving that things are perpendicular. So guess what? It's the same thing that 13 would have, that I don't want to say, because you can read that sheet yourself and try to figure that out on 13 and 14, how to prove things are perpendicular by what the sheet tells you to do. 15 should look a little bit familiar. When did we see 15?
Number 9?
Sort of number 9. But there's another time we saw 15, before we had even seen, there's number 8, but yeah, 8 and 9. But it was yesterday. On the proof you did yesterday, on the back of the quiz that I gave you an answer to, it's that picture. It's just like, yeah, stand it up. So 15 is yesterday's proof, so I don't really want to do 15 either. Let's advance to 16 with the time that we have left. So 16, I've got this, I've got that triangle, I've got this triangle, I got an A, B, P, Q, C, D thing going. It says AB equals DC. Are we happy about those? Yeah, count of 1. It says BP equals CQ. Are we happy about those? No. Why am I not happy about BP? It's not the whole side of the triangle. It's like a half side. BP is like not the full length of the triangle, so my count is like 1.5. AQ equals DP. Am I happy about AQ and DP? Yeah, those are full sides of triangles. So my count's at like 2.5. So now the question becomes, and the sheet knows all the answers, when segments are the wrong size, how do you deal with that? Maybe, maybe not. Angles are the wrong size, for sure. It's AAP. Segments are the wrong size, for sure. Find it on the magic sheet if you must. Definition of between. When segments are the wrong size, it is absolutely definition of between. It might be 8, it might be SPE. We're going to use APE if we want to make the thing bigger, SPE if we want to make the thing smaller. In this case, what you're given, do you want to make it bigger or smaller? Bigger. So that's going to be APE. And along for the ride, for sure, transit. There was a proof that I did, it spelled out Seward on it. It did a definition of between, APE, transitive combo. I drew a big box around it. The big boxed up area on that Seward notes proof, that's what you need to do this 16 with. But it'll be 1 is our givens, 2, 3, 4 would go definition of between, APE, transitive. At that point, you can count to 3, woohoo, triangles are congruent by SSS, and then probably finish with CPCTC, because they're asking you about angle A matching angle D. So if you need some work on that, try to use those example proofs, try to use the statement reason thing, try to get the statements if you can't figure it out. The usual trend of geometry is people usually get a better handle on the reasons first, and then the statements come into focus. You're having trouble getting the statements probably coming into focus just because that needs practice. Okay, so one way to practice that is the 42-point quiz we did that was okay, I gave you the B version of that quiz. You can practice some more, take a picture of the answer key on your way out if you want it. That quiz will happen Friday. If you practice some with this paper, it will help the statements come. The other thing that can help the statements come is using your folder of proofs that you know are right. All the example proofs that I've done, the ones that have boxes around them especially that we filled in as notes, those can give you a pattern of how to try to like mimic these skills, and eventually they'll become your skills. Eventually you're not just copying off my papers anymore, but it'll become your own. But it's going to take a little bit while still to do that.